So remember how I told you that certain data types can only hold certain values, certain kinds of data. So what happens as soon as we try and take a data type like 1.5 and put it into an integer data type? So if I try to hold 1.5 in an integer variable like number 2 right here, what happens is it truncates that decimal. It takes off the decimal part and it just holds the 1. So that's why as soon as I run this program, and notice I can't compile it because this is still running, that's why as soon as I run this program, number 2, the variable number 2, just yields a 1 instead of a 1.5. So that's not right, is it? Because we know that 3 divided by 2 is 1.5. So what we have to do is we have to find a way to hold that data in the appropriate variable data type, or we have to do what's called typecasting. So I'm going to give you a little trick right here. Instead of making number 2 equal to this and then outputting number 2, you can actually go ahead and take this math expression, get rid of this, and put this, and we're going to take that and put it right here in place of number 2. Kind of meaning that we don't really even need number 2 at all anymore. So I'm going to go ahead and delete number 2 up here. Oops, that was 2. Right? Yeah. Okay. So 5 minus 2 is 3, and 3 is still an integer, right? So, and 3 divided by 2 should be 1.5. So you might think that this will actually give you the correct answer still. But the thing is, it won't. It still outputs a 1. That's because 5 is an integer, number 1 is an integer, and 2 is an integer. It's only working with integers, so the answer, the computer will output it as an integer only. And when you have a decimal value output as an integer, it will truncate it, take off the 0.5, so this is not a solution either. What we have to do is we have to find a way for the computer to realize that we are going to be working with decimal values. And there are a few ways we can do that. We can either turn this up here, we can either turn this into a double. I'm pretty sure that will fix the problem. Yep, that will fix the problem because now the computer will realize that this expression is working with doubles. And a double is a higher accuracy. It is of sort of like, you can think of it as a higher order of data. It's more accurate. It takes more information to store a double, but it is more accurate than just an integer. And a computer will always go with the most accurate data type in an expression. In this case, integer, double, integer. So the answer is going to be a double because the double, number 1, is going to be the most accurate. But let's say we don't want to typecast. We don't want to make number 1 and a double for some reason, and there are a few reasons why you might want to do that. Say, memory allocation. I don't want to have all that memory to store a double up here, and it's really not that much, but that's just one of the reasons. There are a few others we'll go over later. Is there any way I can just have it so that this expression is output as a double? So you can actually make it so that singular numbers like this, like 2 or like 5, even though they are a whole number, you can make it so that they are a double, just like having what would the decimal expression of 5 or 2 be? Well, it would be 5.000 or 2.000. So we can actually do that. We can just write 2.0, and now the expression here is going to have a double inside of it because this is actually a double or a floating point because it has this point here, this 0.0. And so this is what typecasting is. You can, there's two kinds of typecasting. There is explicit typecasting, like you can do up here, and I can write double, and it's going to be a double. Or there's implicit typecasting, which is when the computer just kind of infers, like in this expression, what it's going to be. So this is implicit typecasting, and if I were to write up here explicitly double, or another way, is I can put this whole expression in parentheses, and I can write the word double out here. And, well, this won't actually work for one reason. That's because what's inside is going to be evaluated first, and what's inside is going to be evaluated as 1, and that's not going to work. So what we can do is we can actually make it so that this up here, this top part, is a double, and a double divided by 2 is still going to be a double. So this will work. They should output 1.5. Yep. And if I was to make a number inside a double by simply making it like 0.0, it should work if I do it here, but let's just put it right here, 2.0. This should also typecast it up as a double. So you can see how expressions and explicitly stating are two ways that you can change the data type of a variable, of an output, of an expression. So keep that in mind if you ever have any errors in your data and outputting something and it's not quite accurate enough, or it just forgets the decimals afterwards. So that can be one of the reasons. Make sure that you have the correct data type and it is typecasted correctly. Keep that in mind, and we're about to move on to the next tutorial.